Hello everyone, this is Narges. I would like to present our recently accepted paper in the ICFEC conference, which is the abbreviation of the fog and edge computing, and it's gonna be held in conjunction with the CCGRI 2025 conference. The name of the paper is ADAPT, which is related to edge device anomaly detection and Microsoft Replica prediction. It's a collaboration with Nikolay, Radu, Dumitru, Dragi, Frank, and Peter in different institutes all over the Europe, including Salzburg Research, University of Salzburg, Sintef Digital, University of Innsbruck, and University of Klagenfurt. I would like to acknowledge the XDigit project, which is funded by the state of Salzburg, and also Graph Massivizer and Data Pact and Enrich My Data EU projects as well. Firstly, I will give an introduction and then the motivation. I will also talk about the main architecture of the work and also an example and the models and then at the end the evaluations and conclusion. This work is about the edge computing, which is hosting the microservice-based applications. Therefore, from one side, we have the resources which are providing which are hosting actually the microservice executions submitted by their application users. Considering the resources which are being provisioned to the users, they are almost being affected by the stochastic changes due to the different user requirements. From the other side, this microservice-based application management brings some challenges that it will affect the performance, execution from the resource provider and resource provisioner perspective, and also the application provider's perspective. These challenges include such as performing utilization-based events, like for instance overutilization, which here in this work is the basic anomaly that we have been working on to be detected and then to decide what application, what sort of microservice is required to be replicated, is required to be scaled out in response to this increasing load. In this work, we were focusing on the edge devices which have been regularly being monitored. And then on this monitoring data, we applied different machine learning algorithms, including the clustering algorithm, including the ensemble algorithm, and the neural network-based models. The clustering algorithm is specifically the unsupervised k-means algorithm, which has been used to detect the overutilization state of the edge devices. In this work, we focus on two specific states or events of each edge device. One of them, the overutilization, and then the other one is the under or full utilization. For simplicity throughout this presentation, I just mentioned the overutilization and underutilization events. If it comes to the overutilization state, it will be detected as an anomaly for that device. And therefore, what we decide on is to apply the regression models to predict the requirements for scaling out the microservices which have been overloading the edge device. This work was basically part of the Data Cloud project, which was finished in 2023. The tool that was extended in this paper was named adaptation or adapt or adapipe. It was in integration with the other tools such as definition for defining the basic requirements and the designation of the microservice-based applications and also data pipeline. It was using the domain specific language and also YAML to provide this format for us so that we can read really the design of the services and applications. Also, the overall toolbox of the data cloud was included by the simulation, which was relying on the dry runs of the applications to be running and executed on the computing infrastructure. Talking about the computing infrastructure, deployment engine, which was managed by the Greek project partners, where in their tool they have the Mastro. You can also search about it. It was provided by Ubitech company and also based on the Kubernetes orchestration systems. This deployment engine was in contact with the RMarket tool. This RMarket tool was responsible for reserving the resources, the devices in the computing infrastructure based on the blockchain resource marketplace. And then whenever these resources were available, then based on the scheduling and also the adaptation, information and decision that we were used to provide, then the deployment engine used to get this information and deploy them on the computing infrastructure. Talking about the adaptation, in this architecture, you can observe that there are two basic loops in this figure. Both of the loops will receive the information in regards to microservice-based applications and the edge devices. Firstly, after monitoring information has been properly collected, which I can explain it later to you that what were the exact information for us that have been scraped, then this information will be pre-processed, such as, I don't know, differentiation between the row of the data that has been collected for a specific CPU metric or memory metric and a storage metric and so on, and even networking metrics. And then applying some rolling average, and the other one was the smoothing and so on. Then this clustering, which was based on the k-means algorithm, has been applied to detect the overutilization state. If it happens, then we were responsible to apply the prediction, and then when the prediction is available, then we know from which service, how many replica are available, and what are the available devices currently, then to apply the predefined scheduling algorithm over that to distribute them over the computing infrastructure. Let me give an example for your consideration. Assume that there are three different services here which are scheduled on the different devices such as D0, D1, and D0 again. So the requirement have been written here. For instance, M0 requires 4 number of cores and 4 gigabytes of memory. And as we monitor not only the CPU but also the memory of, let's focus on device D0, we understand that through different time slots, through a specific time window, like for instance 10 different time slots, masking the performance of the core and the memory, we observe that most of the time, even more than the average number of time slots, device D0 has been in the overutilization state. That's why we decide to apply the prediction algorithm based on, for instance, the CPU requirement and the memory requirement to understand how many replica from each microservice now we need in order to balance the load. So it's the desired requirements, not just the current requirements. We were relying on the desired ones. So, in a clustering algorithm, we use the elbow method firstly to really get that two number of clusters are really suitable for such type of device data that we have collected from the edge device, and then we try to also plot the main data to see that how many clusters are existing really, and then do they differentiate between the overutilization and underutilization state. So as you see here, also it shows that over the time instances or time slots, most of the time also the device have been in the overutilization state. So just this was about the core. Also, we monitor the memory, and then we decide about this device. How about now that we understood that this device is overutilized, what should we do? As I said, we need to apply some regression algorithms. For that, we utilized 3 different regression methods. One of them was the multi-layer perceptron, which was neural network-based model. A simple one hidden layer and one neuron inside the hidden layer, following the forward propagation and back propagation. The other one was the gradient boosting regression method. It used to estimate and construct an additive model in a forward stage-wise manner. What we really mean by that is that given the data set, it's divided into a smaller sub data sets, and then each data set is passed to the regression tree. In this stage, the weak learner of each stage is passed to the next sub-data set, which influences on the performance of the next stage learning algorithms, and so on and so forth. At the end, the results will be combined, and the final decision tree, the final gradient boosting decision will be passed. We also apply another method, which was the bagging method. In this bagging method, there is no additive model. So like forward stage wise, passing the weak learner to the next stage and so on. It's just applying the regression models, the regression tree in parallel over the subsets of data, and then at the end to take an average over the combined model. The loss over the training iteration shows the optimized model that in each one of this regression model we achieved. Okay, maybe this is just a hint for us, but we need some metrics also to be evaluated. These metrics were like mean absolute error, mean absolute percentage error, root square, mean absolute, root mean square error. Sorry for that. Maybe one other metric was R2 score. Okay, in the future we plan also to target that metric as well, and the training time. You see that MLP is performing almost close to the tree-based model. Okay, one reason is that we really simplified this neural network to have one layer, one hidden layer. It was not deep really, and also inside that hidden layer there was just one neuron. Okay, then the error of the GBR was way less than the other methods, which was the main reason for us to take this information and then decide on the number of replicas that we need. For instance, for the whole number of the whole number of services that were available on that specific resource, and then we evaluate the utilization of the edge device after applying our adaptation method, comparing it with the without any prediction method, which was the first stage and initial stage of the device, and showing that okay, this method had some improvements. Okay. Coming to the conclusion, it shows that the output of this paper, as a reader, if you're going through the paper, in the last slide I will share the link to the paper for your consideration, it was the anomaly detection and replica prediction. Firstly, for getting the overutilized states, and then to predict the replica based on the gradient boosting regression model, which estimates the number of replicas for us for each application, and the results was showing close performance to the actual data. And then at the end, the adapt method was applied and showed lower utilization compared to the state without any utilization. As future work, still we would like to work on this and apply other machine learning models, maybe with more monitoring data, I would say, from the edge devices, and also other metrics, not only the memory utilization and CPU utilization, but also the energy, or maybe talking about the green computing to target the other metrics that can help us for getting the more energy efficient and emission aware, I would say, computing. At the same time, we would like to explore the data privacy from the perspective of the users who are submitting their applications to the computing infrastructure, getting the stakeholders, and like for instance, who is the data processor, who is the subject of this data, what is the subject of this data, and to which rule, how it should be complied, and so on. Yep. Hopefully with the new AI Act and Data Act that is going to be enforced within EU in summer, we can have some achievements out of this scheduling model as well. Let's see. Thank you for your consideration, and you can have access to the dataset that has been shared on Zenodo, and also the main paper that has been available recently on arXiv as well.